Hi everyone. Tonight we're going to take what we've learned about expressions and extend them to talking about equations. So an equation, of course, is two equivalent expressions. So two expressions that have been set equal to one another. So when we're talking about when we're talking about an equation, then we need to make sure that our left and right sides of the equation stay balanced, okay? So that means the left side is equal to the right side. They both stay the same no matter what, okay? So for instance, let's say that I have x divided by 3, and on the left side I have the number 9, okay? So basically what this says is that some number divided by 3 gives us 9 as an answer. Now, when we go to solve to figure out the value of x, we can do that by using the inverse operation. The inverse operation means the opposite operation. So, the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And the opposite of division is multiplication. So in the equation up top, x divided by 3, the opposite or the inverse operation would be multiplication. So what we're going to do is try to isolate the variable. Okay, we're going to be sure to write that down. This is called isolate the variable. In other words, we want to try to get the variable by itself on one side of the equation. So in this case, to do the opposite operation, we would have to multiply by 3. Because in this case, we know 3 divided by 3 would give us 1. So that leaves us just with x. But if I'm doing that on the left side, then I have to do the same thing on the right side. Okay? So what you do to the left, you must also do to the right. Okay, so now we're going to try solving some equations by using that inverse operation. So if we think about this first equation here, x plus 17 is equal to 51. That means that some number, when you add 17 to it, will give you 51. So we can solve that by using the inverse operation to figure out what x has to be, okay? We can use it logically, thinking, okay, some number, when you add 17 to it, it has to give you 51. Well, the only number that does that is the number 34, okay? If I test that out, I can do basically guess and test. 34 plus 17, when I add the 4 and the 7, I get 11. 1 plus 3 plus 1 is going to be 5, so I get 51. And that's the only number that will work. Now, I can also try subtracting that 17 from each side, okay? Notice if I take x plus 17 and I take out that 17, remember our rule says that you must always do that to both sides, then what I'll have left, this plus 17 minus 17 cancels out, right? 17 minus 17 is 0. So what's left on the left side is x. And since I did the same thing to the right side, 51 minus 17 gives me 34. Okay, let's try another one, but this time with decimals. X plus 7.32 is equal to 10.51. I'm going to write this a little bit larger to make it a little bit easier to do my addition and subtraction. That's equal to 10.51. Okay. Now, I want to get x by itself, and I'm going to take away the 7.32. I'm going to do that from both sides. So 7.32 minus 7.32 gives us 0. And on the right-hand side, I have turn this into 11. That'll give me 9. This becomes 4, which is a 1. And then 10 minus 7 is 3. So x is equivalent to 3.19. Okay, for subtraction, we're going to use the inverse operation addition, okay? So if we have a minus 3/7 equal to 13/3, then what I can do is add 3/7 to each side. Negative 3/7 plus 3/7 is going to give me 0. And now I have 13/3 plus 3/7 that I need to add together. So I'm going to use a common denominator of 21. So the 3 times 7 gives you 21. 13 times 7. 13 times 7 gives you 91. And that gets added to 3/7, which is going to change into, well, 7 times 3 is 21. 3 times 3 is 9. So when I add 91 21s and 9 21st, then that's going to give me 100 over 21. And that can be simplified. So 21 goes into 100 4 times. So I've got 4 wholes, and then that's going to give me, so 21 times 4 is 84, which leaves me, the difference between 100 and 84 is 16, so that leaves me with 16 21s. In other words, I can say that A is equivalent to 4 and 16 21s. Now let's try B minus 5.86 equivalent to 9.23. Now I know, similar to what I did before, if I rewrite this a little bit larger, the opposite operation, the inverse operation, is addition. So I'm going to add 5.86 to both sides. Negative 5.86 plus 5.86 is going to give me 0. And now I just need to add 9.23 and 5.86. So 3 and 6 is going to give me 9. 2 and 8 will give me 10. Let's bring over that 1. 1 plus 9 is 10, plus 5 is 15. So B is equivalent to 15.09. Okay, for multiplication, our inverse operation is going to be division. So 6 times a number is equivalent to 12. Some number, when I multiply it by 6, gives me 12. So I can use my inverse operation, division, to solve for x. Remember, division can also be represented with a fraction bar. So if I write 6x over 6, that means 6 times x divided by 6. Well, if I take a number and I multiply by that number, by a different number, and then I divide by that same number, I'm just going to get the number that I started with. So if I take x and I multiply it by 6, and then I divide the whole thing by 6, I'm just going to be left with x. So 6x divided by 6 leaves me with x, and of course I need to do the same thing on the right side since I did it on the left. 12 divided by 6 gives me 2. So if I plug that back into my equation, I can check my work by saying 6 times 2 is equal to 12. Is that true? Yes. So my answer is correct. All right, 13y is equal to 52. Well, that's going to be 13 equals 52. My inverse operation is division, so I'm going to divide by 13. Like we said before, 13 times y, then divided by 13 has to leave me with just plain old y. And if I do the same thing on the right-hand side, 52 divided by 13 is 4. I can check my work like we said, by doing 13 times 4 to get 52. And if you don't believe me, think about a deck of cards, right? Each house within a deck of cards has 13 cards, and then there are 52 cards total. Okay, so last step is division. We're going to use z divided by 4 being equivalent to 3.5. Now, I find it easier, personally, to write a division problem as a fraction. So I am going to write this as z over 4 equals 3.5. I find it easier to work with. You can choose to continue to work with the division problem as it was written up top, if you prefer. But z divided by 4, giving me 3.5, means some number. If I take that and I divide by 4, I'm going to get 3.5. So to solve, I'm going to work the opposite direction. I'm going to multiply by 4. So 4 times z, and then divided by 4, is going to leave me with just plain old z. If I do that, then I have to also do the same thing to the other side and multiply the other side by 4. So that means I have 3.5 times 4. 5 times 4 is going to give me 20. 3 times 4 is 12, plus 2 is 14. Now I have to do my decimals. Remember, I have one decimal place here. It is 0 here, which leaves me with one decimal place at the bottom. So I'm going to start from the right and move one spot to the left, and I have 14 as my answer. Z is equal to 14. And W divided by 8 being equal to 96 means W over 8 equals 96. Some number divided by 8 gives me 96. So now I can work through this problem by using the inverse operation of multiplication. W divided by 8 and then multiplied by 8 will give me just plain old W, and I need to do the same thing to the other side. So now W is equal to 96 times 8. If I do that multiplication, I'm going to do that on the side over here, 96 times 8. 6 times 8 is going to be 48. 9 times 8 is 72. Plus 4 is 76. So W is equal to 768. All right, that concludes our notes on solving one-step equations. Now I'd like you to give the backside a try on your own, and I will give you the answer key when you show me that you are ready and you have the backside completed.